welcome to our teaching vlog. Have you ever noticed that sound travels differently during hot and cold weather? Today, we are going to discover how particle movement and temperature affect the speed of sound. We'll learn why sound moves faster in warm air and slower in cold air through simple explanations and real-life example. So stay tuned and let's explore the science of sound together. What is sound? Before we understand what affects the speed of sound, we first need to understand what sound actually is. Sound is a form of energy produced by vibrations. When an object vibrates, it causes nearby particle to vibrate too. These vibrations move from particle to particle, creating what we call sound waves. Think of it like dominoes. When one domino falls, it pushes the next one, and the motion continues in the same way. Vibrating particles transfer energy and to neighboring particles. How sound travels? Sound travels through mediums such as solids, liquids, and gases. A medium is simply the material through which sound moves. The movement of particles in these mediums determines how quickly sound can travel. In solids, particles are tightly packed together, so sound travels very fast. In liquids, particles are less tightly packed, so sound is slower. While in gases, particles are far apart, making sound travel the slowest. That's why sound travels faster in steel than in water, and faster in water than in air. Now let's focus on particle movement. Particles are constantly moving. The amount of movement depends on the energy they have. When particles move faster, they collide more often and transfer sound energy more efficiently. This means sound waves can move faster through the medium. The role of temperature. Temperature plays a huge role in particle movement. When temperature increases, particles gain more kinetic energy. Kinetic energy is the energy of motion. So when air becomes warmer, its particles move faster. Since particles are moving faster, they can pass vibrations more quickly from one particle to another. As a result, sound travels faster. Let's compare cold air and warm air. In cold air, particles move slowly, energy transfer is slower, and sound travels slower. While in warm air, particles move quickly, energy transfer is faster, and sound travels faster. Scientists use formulas to calculate the speed of sound in air. Speed of sound formula is V equals 331 plus 0.6 t, where V is the speed of sound in meters per second, while T is the temperature in degrees Celsius. This formula shows that as temperature increases, the speed of sound also increases. Let's try an example. What is the speed of sound at 30 degrees Celsius? Using the formula. So the final answer is V equals 349 meters per second. So at 30 degrees Celsius, sound travels at approximately 349 meters per second. Real-life applications. First is thunder and lightning. Have you noticed that you see lightning before hearing thunder? That's because light travels much faster than sound. The temperature also affects how clearly and quickly thunder travels. Second is music and instrument. Musicians also experience the effects of temperature. In colder environments, sound travels slightly slower, which can affect tuning and instrument performance. Third is sonar technology. Submarines use sonar systems that rely on sound.